Welcome back to the main stage, and I'm very guys in the back. So, yeah, please spend attention, people. So, I'm very happy and honored that we have Pascal with us. Pascal is the scientific advisor of the French embassy in Germany. So he's probably often working in the building nearby to us here. And it's a great honor and pleasure having you here. And he will also give us some greetings from the French embassy. And yeah, thank you very much for that. And I directly hand over to you.
Thank you, Mark Oliver. So I was not sure about the language, but I finally decided I would speak in English rather than in French or German. I think it's okay for everyone. So I'm very pleased that you invited me to come here today for the fifth edition of the Future-IoT PhD Summer School. And I'm also pleased that Berlin was chosen as a location because Berlin is a very nice city. And it's also one of the best places for innovation in Germany. Munich and Berlin are probably the best places in Germany for that. So you are here at the heart of innovation, and I think that's, especially in this neighborhood, in embassies next door, it's not a place for innovation, but it's also a great place to be. And I'm sure you enjoy the city. Thanks to the organization committee, especially to Mark Oliver and the Institute Min Telecom, at least the Atlantic branch, if I understand correctly, and the Academy, the French-German Academy for the Industry of the Future, and also the Technical University of Munich, which is part of it. I'm pleased to see so many participants. Congratulations. And so here live and also online, I heard that there's a lot of them who are online also. So congratulations, you made a right choice in coming here and to participate in this exciting and very diverse program of activities. Yeah, you made the right choice because international cooperation is important, and I would say in particular the French-German cooperation for the future of Europe. And it's important because it's not natural, it's not easy to cooperate. We must make efforts for that. And these efforts must be again and again and stimulated all the time. So we have a lot of selection for projects we have in the bilateral calls. And well, you are the next generation of the cooperation between France and Germany, so congratulations and enjoy your time here, and I hope you enjoy also the international cooperation. I heard that the topic is oriented towards mobility this year.
It's autonomy.
Autonomy.
IoT meets autonomy,
okay.
But mobility is a very important point as well.
I'm very excited to know that we also have some representatives from the industry that we will learn more about the future of autonomy, autonomous flight perhaps, and mobility, thanks to our representatives from Airbus. So thank you all, and I give the floor to my follower perhaps.
Thank you very much. Okay, perfect. Thank you very much, Pascal. And that brings us to the next speaker. And the next speaker is the next Pascal, so it's easy. You can either put your PC down, this is what I always do, or I put mine down, as you prefer. You can already connect it. So Pascal Travis from Airbus will be talking about autonomy and innovation as enablers for the aircraft industry. And as usual, some words about Pascal, and then we have the trailer to his talk. So Pascal Travis is building Airbus Strategy around autonomy technologies, automation, human-machine interface, and so on for the whole Airbus, launching the projects that are needed to fuel that strategy, fostering synergies within Airbus, and then participating in their steering. He participated in fly-by-wire development from A320 to A380, mostly on system architecture, safety, and certification. Outside Airbus, Pascal contributed to the first version of the ARP 4754 and regulation harmonization with EASA, FAA, and so on. He then managed Airbus system safety activities and later on part of A380 manufacturing quality, final assembly line, and so on. Pascal Travis is a fellow of the AAAF, the Aeronautic and Aerospace Association of France. His doctorate is from Toulouse Institute National Polytechnique N7. Pascal worked on research in LAAS, Laboratoire d'Analyse et d'Architecture des Systèmes Toulouse, and UCLA, University of California in Los Angeles. So let's hear what Pascal says he will be talking about.
If we look at the record on aviation safety, we see a clear improvement and we see a correlation with the level of technology and the level of safety improvement. A key question there is there a causation, some key technologies that have clearly improved safety in aviation? That's the first point. Second point, aviation is moving very carefully for pretty obvious reason. And in this very constrained environment, is it possible to innovate, to invent new ideas?
Okay, and this is a very good question. Is it possible to innovate new ideas? And with that, I hand over to you.
So the answer is yes, bye-bye. So thanks first for the opportunity. It looks very much like Airbus more and more in the sense that when I entered, I was the youngest, then I've been hiring people the age of my kids, and now I see people like you younger than my kids. Okay, that's life. At least you are older than my grandchildren. That's I feel less strange in this world. By the way, the biography that my assistant provided is the one which is published in writing, not the one we are reading, because it's a bit long. Like a long career. Anyway, so I had a first difficulty when I was invited to come is to see the link with Internet of Things. And so I've been looking at the things we are manipulating, and while we may have a dozen assets flying together and coordinated, be it for military purpose or for urban air mobility, for example. But these items are a few tons, so it's not exactly what you are dealing with. So I didn't feel at ease. So something I will try to address instead is rather to look at innovation. There are a lot of books on innovation, how to innovate, efficient, blah, blah, exponential organization, and so on. And so I will be taking the example of our cockpit to show you the way we, in practical terms, we are innovating in aviation. And so it's a disco, something which was almost finished before you were born, but that's life. Okay, so if we look at statistics, well, you have the numbers, you are scientists, so you see time on one axis and number of accidents, and clearly it is going down, so that's pretty good. That's good even, and we have 4 different curves based on the technology level. So I will not enter into the details, but in the history of aviation, we can see significant change in the way the airplanes are designed, and we have classified that in 4 categories, and we see that there is, the number is better, so better to take the last years before a generation is lost, but you see that well, there is a trend toward 0 accident. It's not yet there, and even if the curves are very close, well, anyway, it's a ratio of 3, which is not that bad as an improvement. So with technology, with the level of technology, we see an improvement. Is it the root cause of this improvement? You may have in mind that, well, the later generation are younger, meaning that certification authority like EASA in Europe or FAA are adding more and more requirement each year, and it never goes down, the level of requirement. It's always going up for safety, and based on what's happening in real life. So the level of certification is always more and more stringent, and that's one point leading to increase of safety. We have also the fact that airlines are more and more implementing what we call a safety management system, which is the analysis of low amplitude signals to identify, well, I have not an accident, but possibly adding an event, I could have an accident. So what in my culture I should change to improve safety? And it's the same also for aircraft manufacturers like Airbus, who are monitoring low-level accident, low-level incident to understand if we need to do something now or in the future. So safety management system. Also, you may not know that, but training also is something that we are improving year after year to get pilots that are more trained and more able to handle events that may occur. So there are several things that we are doing. Anyway, if we go down to a bit of details on the root cause of the accident. So looking at the 3rd and the 4th generation, the big difference is on loss of control in flight. Loss of control in flight, typically the airplane is flying with a too high angle of attack. At some point, the airplane stalls and may fall down. And the big difference between the 3rd and 4th generation is a fly-by-wire system that was introduced first by Airbus, and I was a very junior member of that team. So kind of dinosaur in Airbus now. So, and with this innovation, we have put some protection which are allowing the airplane to control the angle of attack and to avoid entering into a stall. So this kind of function, which is now used in the Boeing airplane and others, so everybody is moving, and this kind of innovation is targeting this kind of accident, and we see the result on the numbers. So it sounds good. And if we look at from the 2nd to the 3rd, where we see a big improvement is on the controlled flight into terrain. That's the way we call this kind of accident, meaning the pilot is lost, and at some point the airplane is encountering the ground. And for that, the big innovation between these two generations, there is people with a T-shirt written Riot. They are down in the street, I believe, no? No, it's not that. Okay, so the difference between second and third generation is that we have introduced satellite navigation system to detect the terrain, to warn the pilot that it is coming too close to the ground, so, and a better navigation system. So with this kind of system, the aim was to better know where the airplane is, to be sure that we are far from the ground. And indeed, we see an improvement in the number of accidents. On both cases, it's division by 4 or 5, so it's really significant. So yes, this kind of technologies, automation, perception, navigation, better human-machine interface, all these technologies are able to improve safety, and so we have seen this big step of safety improvement. And what we are doing is we continue. So we have a big step, which was introducing a flight envelope protection in the 80s, in the last century. And since we are continuously improving our product with more robust autopilot, with some warning and so on. So right now we are in an incremental approach. We are adding function one after one, which is not a new generation, but is something that will improve safety. So good, incremental, step by step, but are we able to do something more ambitious? And that's where an innovation process is coming. So we want to innovate even more, to be even safer. So what we have done, so we have read book on innovation, and we have started giving to a team a target which is, well, I think it's possible to get it, but they will have to do it after I retire. We set a very high target and ask the team, reach that target. Find ideas. You can be in rupture, you can disrupt Airbus with something completely new. Reach this target. And this target is first to enhance safety. Second, to enable single pilot operation, meaning to have only one pilot in the cockpit. And beware, these two objectives are very close, because if we have only one pilot on board, this means that we need to be error-proof. We need to reduce the risk of the pilot making a mistake. And if the pilot is making a mistake, we need to recover that mistake. So we need systems that are far more resilient. And that's good also with two pilots. If we have only one pilot, we need to give time. At some point, we have to cover the incapacitation of the crew, meaning that there is no more pilot on board, and this means that the airplane is very automatized. And if we want, on a classical cockpit, to improve safety, something which is absolutely needed is to give time to the crew, to give them time and the information, the data, so that they can assess the situation and make a good decision. So in terms of technology, robustness of the autopilot, automation, human-machine interface, we find quite a lot of common between this economic objective of single pilot operation and just improving safety. On top of that, also, we told them reduce recurring cost, non-recurring cost, the weight, the drag count, the volume, everything. That's in aviation, we are always fighting the weight. And also, we have some principle in our architecture. We don't want a pilot coming from the 320, for example, to come in our new airplane and being completely lost. So we need some basic to keep. And so go radical. So that's the target. Then the means. So it is a team of pretty young people, a bit sometimes maverick, and we let them start from a clean sheet. You don't need to start from current cockpit. Okay, there will be a training. We will need to train the pilot. They will not be able to go from the 350 in the cockpit of the new airplane. Okay, we agree on this cost, so go for something completely new. and we gave them tools to work quickly. So the first tool was a saw. So they designed a cockpit. So our first cockpit was in wood and designed with a saw, so something very simple. So, but also other tools in terms of model-based system engineering, in terms of 3D printer, things like that are also tools that are useful to work quickly. And they have done quite a lot of very good ideas, so it was absolutely necessary to kill the ideas as soon as possible, because we have limited resources, so we need to be selective. So the idea is we create a lot of ideas, then we check these ideas, and if we can kill them, well, okay, but we better know it very early rather than 1 year, 2 years, or something like that. And for that, so we are using expert for assessment panel. We have also made a lot of test bench, so one to integrate technology, and also one which is particularly useful, which is, we call that the disco deck. Deck is cockpit quite often, and the goal is to have something easy to modify, and where we can put pilots. It's a cockpit, so we need the feedback of the pilot. We need them to feel engaged, to feel good in that cockpit. And so we put our test pilot first, then pilot who are training other pilots in Airbus. Then we went to airlines and telling them, why don't you come in Toulouse, you will see a marvel. And we got two types of feedback. Both were very good, very useful feedback. Quite a lot were telling us that's exactly the cockpit of the 21st century, thanks to do it. And a lot of them were, this is bullshit, and so you better change this, that, this, and that. But basically, the principle are agreed with quite a lot of pilots. We have to work out the detail, but basically, what we have is pretty good. So having feedback from the users is something mandatory, and so building the tool to get this feedback is also something we have to do for innovation. We have also a mechanism to put in flight new ideas. So if we want to have an autopilot that is always available, this means that the airplane is able to land even without navigation aid like instrument landing system. So this means that the system has the same means as the pilot. It is to look outside and to detect where is the runway. And so if this doesn't work, well, we can forget about the always available autopilot. And so we have modified one of our airplanes with camera, and we landed. During the COVID phase, we were able to land and take off in Toulouse. So there is 2 runways. You come from the south or from the north, so that's 4 different runways seen from the computer. So that was quite. That's a start. So the idea was either it works or we stop it. So it works. We have not yet demonstrated that in all weather conditions, but at least in reasonable weather, it works, so we continue. And now, the first demonstrator on the atoll was, I demonstrate the landing completely autonomous. Now we want to demonstrate that if from the flight in cruise above the ocean, I'm able to go down to an airport to land, even if I encounter a bad event like weather, bad weather, something like that, changing, a failure, that the airplane is still able to reconfigure and to continue. So these are the fail fast is mandatory. I mean, we have limited budget, limited resources, of course, even if it's not that bad. So we need to be able to select the ideas. And of course, we are working with quite a lot of people, mostly French, by the way, because cockpit is French and in Airbus. And the money of, after the COVID, France was allocating quite a lot of money for research, more than Germany. That's life. And out from that, So we have worked quite a lot of technologies. So from the concept of operation, because well, if you have only one pilot, it's not you don't operate the airplane as if you have to. So regulation with airworthiness authorities, down to how are we going to trust this system. The confidence in the system is mandatory. So we need to work on that. So possibly by testing, massively testing millions of test cases. We may be using some artificial intelligence, not too much, but at least we are testing different solutions with typically landing, recognizing where is the runway. We have tested some machine learning algorithms, and it works pretty well, particularly when we are far from the runway, when the runway is a set of dots in an image. And when we are getting closer to the ground, we have been able to test another algorithm, which is completely stupid, and we like that very much, which is, I look at a runway that's a line of whitish dots surrounded by grayish dots. And a classical algorithm can do that, and maybe safer getting close to the ground. So testing, validating, being confident in our system is something also that we have to work closely. And then quite a lot of technologies. So working with the pilot, so engaging experience, human-machine interface, to be sure that he will find the information in time at the right position. Also monitoring the health of the pilot, being able to tell him, well, you look tired, why don't you take a nap or something like that, and I take care of the rest. That's monitoring the fatigue of the pilot is something that may give some value to aviation in the future. And also everything on automation, like detection of obstacle, autopilot, and so on. And at this point in time, we are at a step where, well, next airplane, we will put all these safety improvements, provided we are able to mature them, because we are still working, this is research. So that's very, well, we are very happy with all the innovations that we have identified. And for single pilot operation, well, we'll see if the market wants it. We have mixed feeling about that. But if they want it, we will know what is safe and what we must avoid. So anyways, the result of the study is interesting. And that's all what I have prepared, but I'm ready to take question if any. I don't know, Mark Oliver, if that's the plan, or are you expecting me to dance? Because no way.
We still have time. You can also talk more if you want. Besides that, we can also go to the Q&A. It's not fun for me. So do we have questions? We have still plenty of time, so we can do lots of questions. It's good. And first of all, let's thank Pascal for
Thank you for this nice presentation, but why not zero pilot?
Well, in the literature, you may find some paper stating that I think it's 2045 that possibly the machine will be more clever than a human. Okay, fine. Waiting for 2045, we still believe that if we need to invent a solution, a human is better than a machine. For example, well, we have cases, I'm not sure I will go down to these details, but we have cases where clearly the solution was not in the book. It was the first time the event occurred in the history of aviation. And the pilot, normally in the paper, the airplane is lost. Right? And the pilot find a solution. So sometimes it's unknown, you may find. So sometimes a human is able to find a solution to an unknown problem, and we are not ready to believe that the machine will be able to do it. So we wait 2045, and we'll see if the machine are better than the human, and then we may change our position.
Thank you.
Okay, next question.
Thank you for your presentation. Now, switching from a two-pilot cockpit to a one-pilot cockpit, aren't you afraid that the pilot unions will get a bit mad that you are like ditching one job technically from the plane?
Well, if you, some people may not be happy about that, but it's very likely that in 2 or 3 years, the increase of the number of airplanes will continue on the same pace as before, and with that, we are faced with a shortage. And so, looking at the number of pilots, so perhaps things will change with regulation of the climate or something like that. That's another debate. But with what we have in hand, it looks like the number of airplanes will significantly increase. And this means that the shortage we have in terms of pilot will continue, and it will be even more. And so for the shortage, it's not single pilot that will solve the issue at all. It's too much in the future. So it will be through training, so perhaps better salaries and things like that. But anyway, with the increase of the number of airplanes, the day we put our airplane with only one pilot, it will not be significant. Even after 10 or 20 years after the entry into service, there will be still such an amount of airplane with 2 pilots that it's not an issue. After that, yes, pilot unions have a concern, but the concern they have is basically about safety. So yes, indeed, having 2 pilots, there are quite a lot of. We count on one pilot to monitor what the other is doing, and so their questions are legitimate, and we have to answer them. So I would say the unions are more asking good questions, not always in the way we would ask them, but anyway, they are asking a lot of questions, and we have to find a solution. So it's interesting to get what they say. After that, perhaps there will be some struggle of power inside airlines, so but we'll see. But at least the concerns they are raising are interesting to look at.
Thank you.
Thank you for your presentation. And we're referring to test cockpits, like the wooden ones. Have you thought like maybe going towards the route of virtual reality so pilots can experience much faster instead of building a real sort of like one and then getting them into it?
Yes, we have one with virtual reality, and but well, first they want to touch, so they need to touch something because there is sticks or screens, touch displays. They want to touch it. So we have made something which more augmented reality, perhaps maybe more the word. So with some controls plus the rest completely virtual. It works. At some point, we decided that we were mature enough to go for a real cockpit.
Thank you.
I was unluckily outside for some minutes, so maybe you talked about it already. So what is the role of AI in these assistance systems? Do you see AI coming? Which potentials and which risks do you see in it?
Yes, so yes, we are testing that, particularly deep learning. So the landing system we have tested was based on images. We are feeding images to an algorithm, and we get it. So right now, first, we don't intend to learn during the flight. We freeze the standard, and we fly with that. Possibly we'll make an update 3-6 months later, but we freeze the standard. We don't learn continuously in flight. That's one point. Second point, right now we are more in looking at a few very specific functions, like the speech, analyzing the speech of the air traffic controller, analyzing the image. On this very specific function, we can embed these functions into a safety net, let's say, we can add monitors. We feel safe. we have anyway to be confident in this kind of algorithm, which is not designed. We are using a waterfall in our design. So we have the requirements, we validate the requirements step after step, and then we have the code, but we can trace everything up to the requirements. Here it's a bit more difficult. It's not a bit, it is more difficult. So the confidence in this kind of algorithm, it's not a given. So that's the main risk that I see for acceptance.
Mm-hmm. And explainable AI, do you have a comment?
Yes, very good.
That?
Yes. We're investing in that. I hope it will not be 2045, that it will come earlier.
Mm-hmm.
But well, yes, there's quite a lot of investment in several research institutes, and yes.
And what potential do you see? So what would be an application where you would say AI would bring us something? Are there some concrete applications you have in mind?
Definitely. I mean, recognizing the runway from an image, detecting an obstacle on the taxiway, things like that. But it's a pretty isolated function in a whole cockpit. Mm-hmm. The decision making, we think that or sometimes kind of symbolic AI perhaps, but anyway, it's something that we can understand very well, all the steps. So
okay, good.
And we keep a pilot, by the way.
Okay, cool. Thanks.
And with respect to shortage of pilot, a solution is to get more women in the cockpit, because you are not a lot. It's 5%, I think. So I mean, if you, well, it's like here, by the way, same proportion as this room.
My question is concerning like the current state of automation. So if we take, for example, a transatlantic flight, how much percentage of the time flown is already completely automated, and how will this develop in the next 10 to 15 years to your estimation?
Yeah, sure. It's right now for a flight. Usually, the pilot is taking off, controlling the takeoff, and and perhaps one landing out of two is automatic, and in cruise it's automatic. So the time for the pilot acting directly on the controls, it's a few minutes per flight. That's all. And so that's one of the reasons why we have changed our training to be sure that the pilot understands the basics of aviation, that there is flight mechanics, and if you make too much angle, it falls, that if you roll too fast. The basics, the flight mechanics, we have changed the training to be sure they understand that. Because in practical day, they are pressing buttons.
Yes, just a question. Do you also work on urban air mobility, and what do you expect for this new technology in the coming years? Will it be a reality?
Well, at least the investments are huge. There is an amount of money which is enormous. And you see the difference between a company where we need to provide a return on investment every year to the investors, and other market where people are putting money, but okay, if it is lost, it's 500 million. Okay, what else? Who cares? So it's a very strange market. So there is a lot of money, a lot of buzz. Then, so we are working on it, frankly, but is it a market? It's a real question. In terms of technology, it's likely that the first taxi like that will not be taxi, but buses, in the sense that they will fly in corridor. So there will be only 2 or 3 places in a city, and the taxis will go from these cities from this spot, and following a very precise route. And so it's pretty limited. And here we have an issue with the pilot. It's not so much the salary of the pilot, but more a snowball effect, is that if you remove one person from the vehicle, then you save 1/3 or 1/4 of the batteries of the size of the propeller. And when you have reduced that, you can start. This means that you need less structure to sustain all of that, and you start again to optimize the vehicle, and then you can save a lot of weight, and then you can save with the batteries, there is some capabilities, but it's not so easy. Well, you look at a car, and there the power is even better, or higher. So autonomy has clearly a value, but is it a real market? While we are investing in it, yes, not hundreds of millions. That's not not our case, but we'll see. It's not so obvious. Yeah.
Okay, I have a question actually, is moderating Q&A. Today, is it possible to control the plane outside the plane, maybe from a center? If yes, to what extent?
Right now, it's possible for a drone, that's feasible. For a civil aviation airplane, from the ground, you can upload a flight plan. So making the main milestone of the flight, but it's the pilot is entering them is clearing each of these milestone step. So right now on a civil airplane you cannot control from the ground. In the future, that's something we are not investigating. Even I understand that quite a lot of you are working on cybersecurity. I don't trust you. So we are not. It's not an hypothesis to control the airplane from the ground.
Okay, follow-up question. Even though you don't trust us, it's like remote control is something happening also in like nuclear reactor factories. Even though you don't trust us, because it's so ease of use. So remote control is something. There are also a lot of advantages. So what would you comment on in the future? It's inevitable. It's coming. Remote control of airplanes.
Not in my backyard, not in my plane.
Okay, well answered.
But anyway, anyway, when I say that a flight plan can be proposed from the ground to the flight, this means that data are coming from the ground to the flight, to the airplane, and we have to be sure that these data are safe and secure. So we are anyway interested in cybersecurity, and it's very important also for civil aviation, but not to control the airplane from the ground.
Maybe related questions. So there was this incident, I think it was almost 20 years ago, on the Lake of Constance, where two planes crashed because aviation control told both to go to the same level. Did things evolve since then? Is there a possibility or probability that ground control will have more assistance, and that such things that could algorithmically with deterministic algorithms be resolved?
Yes, right now there is a system called the TCAS, and each airplane is broadcasting its position, its speed, and its vector. And there is an algorithm in both airplanes that, and based on the location of both airplanes, there is a non-ambiguous decision. One is to go up and the other to go down. So normally this should not happen. Mm-hmm. With airplanes which are equipped with this system, broadcasting their position. And as you may know from this summer, even corporate jets are broadcasting their position. And so the issue may be with a drone that you are playing with or something like that. The issue is more closer to the ground with small things that people may play with. General aviation, I think it's a small airplane. I think it's mandatory in the States, I know, and I think also in Europe, that small airplanes that you play with are equipped with this kind of system, broadcasting their position. So it should not be.
And follow-up question: there was this MH370 that was going down probably over the Indian Ocean, and it was just too far away from the radars, and so therefore one did not know where it is, or at least the official version is one does not know where it is. At the same time, I read that there was information sent to Rolls-Royce because of the engines during the entire flight, even though they didn't have a subscription via satellite link. Can you say something about the state of machine-to-machine communication between airplanes and so on? Because I know that internet, there's a thing that the planes might make a mesh for providing internet, but is there communication between these planes? Is there something that changed after this MH370 incident, that planes are globally trackable now or something like that? Is it desirable? Why not?
Yeah, I'm not familiar, but yes, since that event or also another event, there are some regulations so that what is called la boîte noire, the crash register recorder must dump some data. So I think there is regulation in it, but not familiar enough. For sure, connectivity is increasing. There are a lot of promise from connectivity. And even already Inmarsat and Iridium are providing quite a wide coverage, but possibly we'll have some constellation of 2,000 or 3,000 satellites in a few years, enabling you to watch Netflix on your PC and accidentally to provide safety information. But in terms of data flow, it's nothing compared to.
And
driver.
If nobody asks a question, I continue. So there were efforts, and I'm sure there still are, towards removing the cables because there are several tons in the plane and replacing them by deterministic Ethernet, for instance, and also fly-by-wire and so on. So how is the status that you can communicate of that today? Will it be evolved further? What will be the outcome in the end of that? Or what could be an expectable outcome at the end?
So in the fly-by-wire, on the S320, it's the highest technology is one bus, so one computer sending information to 5, 6, so monodirectional bus. So you multiply the wire and that's it. On our latest airplane, we have made a giant step, which is to use a multiplexed bus, the 1553, which has been designed in the 60s. So, but we understand very well what's going on the bus. We like it. Voilà. And we have also some on other part of the avionics. On S380 already, we have a data bus, which is a kind of deterministic Ethernet. Yes. I don't remember. RING 653 possibly. I'm not so sure, but yes, we have that since the S380, so 15 years ago about.
Mm-hmm. Okay, cool. Next question I would have is, so when you look at car companies, BMW for instance, they are now producing cars where you can buy features, or Tesla started that. So you can now buy the heating system and so on. Is that a business model that you will also find in planes in the future, that you say, okay, now you have better, whatever, air conditioning, the heating is working even better, so like not only entertainment system functionality, but also other functionality? Is it something that will come? And related, or even before this question, is over-the-air updates. So if I understood it correctly, airplanes are currently not at all updated. You buy them and then they're there, and if there's not something ultra-critical, normally you would not roll out a software patch on it. But is the development going into that direction?
Software patch. Horror. So we have options already that the airline can buy, mostly on the cabin. That's it. Then to update the software, right now we can do it on the airplane, but you have to come with a dedicated computer to plug it and update the software. And the software has been completely certified as for the first time it has been certified. And beware that it's a very different market. I don't know how many customers we may have in the world, but I think it's about perhaps 400 airlines at all. It's not like when you sell a car, 2 million cars per year, we have only 400 customers. So it's very different. And we may try to tap on the passenger market to sell something to the passengers, but usually the airlines, they prefer to do it by themselves. So we have to be cautious.
Okay, so last chance for a question. Do we have some more questions? If not, Pascal, both Pascals, you're very lucky because finally the t-shirts arrived. You will get yours tomorrow, almost certainly. So this is the t-shirt. And yeah, thank you once again for the talk. And yes, you have one reward.
Thanks for the t-shirt and the opportunity to be with you.
Very good. And for you, I also got one. You're welcome. Okay, and then yeah, thank you very much. It was super interesting also hearing something about this use case. Our next program point is that we slowly walk to the beer garden with a short detour of the parliament and so on, and we'll do it immediately. So it's now 43, so that means we would depart in about 10 minutes. We'll not come back afterwards. That means if you want to take things to your hotel and so on, please take them with you. You don't have to if you don't plan to submit a paper tonight and want to leave your computer. Feel free to do it. We will lock the rooms again as we did yesterday, so no worry about that. So I would propose it's now 45. In about 8 minutes, I will walk from the upper floor down again and lock the rooms, and we gather here, and then we go with Tim to the beer garden. Okay.